Today we'll discuss about the routing configuration, routing protocols in Palo Alto Firewall, architecture, configuration, real-world troubleshooting. In today's session, routing architecture in Palo Alto. Routing is configured inside a virtual router. A virtual router maintains routing table, runs dynamic routing protocols, performs route lookups before policy enforcement, supports multiple VRs per firewall, traffic flow simplified, packet received, route lookup, virtual route session created, policy lookup, NAT, forward, IP routing, fails, no session created. Types of routing supported: static routing, manually defined routes, configuration, network, virtual route, static routes. In CLI, configure set network virtual router name, routing table IP, static route, name, destination, subnet, next op IP address, gateway IP, commit. When used, default route ISP, small networks, backup routes, VPN routing. OSPF, Open Shortest Path First, Interior Gateway Protocol IGP, used for enterprise core branch connectivity, internal dynamic routing, supports areas, DR/BDR route redistribution. OSPF configuration path, network, virtual router, OSPF, CLI. We need to set the command set network, virtual router, VR, protocol, OSPF enable S. Set network, virtual router, VR, protocol, OSPF area, we need to define. BGP, Border Gateway Protocol, used for ISP connectivity, data center peering, cloud routing, SD-WAN environment, supports EGP, IBGP, route filtering, local preference, MED, communities. BGP configuration, network, virtual router, BGP, CLI. We need to execute the command set next network virtual router via protocol BGP enable S. Set network virtual router protocol BGP local AS number we need to define. Route types in routing table. So the code we need to remember while working on a routing part. S means static, O means OSPF, B means BGP, C means connected, R means RIP, A means aggregate. So these are the routing codes which we need to remember when checking the routes in the CLI. Routing troubleshooting methodology always follow this order: interface, ARP, route exist, correct next hop, return route, policy, NAT. Case 1. No connectivity to remote network. This is an example of a case where what we need to check when there is an issue occur. We need to check the route, show routing, route in destination, remote IP no route, routing issue. Step 2, check the interface status, show interface all. If interface down, routing won't work. Step 3, check ARP resolution, show ARP all, no ARP entry, no next hop unreachable. Case 2, route exists but traffic not passing. Common causes: asymmetric routing, NAT interference, security policy block. Check the session, show session, all filter destinations, IP address. If no session, route mismatch. Case 3, OSPF neighbor not forming. Check the OSPF neighbors, show routing protocol, OSPF neighbor. If empty, common causes: area mismatch, hello dead timer mismatch, authentication mismatch, network type mismatch. Check OSPF logs, less MP logs routed log. Check the interface OSPF config. Show routing protocol, OSPF interface. Case 4, BGP peer not establishing. Check the BGP summary, show routing protocol BGP summary. State meanings. State meaning: idle, not connecting, active, trying to connect, established hub. If we stuck in active, check TCP 179 allowed, peer IP correct, update source correct, AS number correct, test the connectivity, telnet peer IP, port number 179. Check the BGP logs. In case number 5, BGP established but routes not installed. Check. Show routing protocol BGP ready bin. IP routes received but not in routing table. Possible causes: route filtering, administrative distance, better route exists, next hop unreachable. Case 6. Asymmetric routing problem. Symptoms: one-way traffic, encap counter increases, decap 0 VPN, sessions reset. Check show session ID. Look for TCP reset from the server. Verify the return route on remote side. 7. PBF overriding route. Check show running PBF policy. PBF may send traffic to the wrong ISP. Disable temporarily to test. Case number 8. ECMP issue. If ECMP is enabled, show routing route. Multiple equal cost routes may cause out of order packets, VPN instability. Advanced CLI diagnostics. Check route lookup for specific IP. Test routing, fib lookup, IP destination, virtual router, VR name. Show exact next hop decision. Check RIB versus fib. RIB is routing table, show routing route. Fib is forwarding table, show routing fib. Mismatch indicates hardware programming issue. Real world enterprise routing failure example scenario: after ISP failure test, internet not working. Default route present. Root cause: static default route at lower metric than BGP learned route. Firewall: preferred static route to down ISP. Fix: increase the static route metric. Senior engineer routing checklist. Before blaming the firewall, interfaces up, ARP resolved, route exists, route preferred correctly, return path exists, policy allows, NAT correct, no PBF interference. Most common enterprise routing mistakes: missing return route, wrong next hop IP, BGP AS mismatch, OSPF area mismatch, static route metric misconfiguration, NAT applied incorrectly, PBF overriding route, ECMP instability, VR misassignment, route redistribution misconfiguration. Interview ready summary. Palo Alto network supports static routing, OSPF, BGP, RIP, policy based forwarding, ECMP. Routing happens before security policy, before NAT, inside the virtual router. This is end of the session. Today we discussed about the routing protocols and the case studies of the example, explaining that whenever the issue occurs, that we have discussed in checking the CLI to make sure that all commands are handy before doing any kind of a troubleshooting. Thank you.